Assalamu alaikum students. This is Dr. Muhammad Munir Omar with CS222 Database Management Systems. In today's lecture, we will study about Entity Relationship Diagram or ER diagram, also known as ER model, Entity Relationship Model. So these are the outlines for our today's lecture. First, we will look into database design, then entity type, attributes, relationships, and we will have some examples, and after that we will discuss a complete ER diagram. So for the development of application program, whenever we are going to develop an application program, the first thing is requirement collection and analysis. This is the first stage actually whenever we want to develop a software. So in the collection of requirements and analysis procedure, what we do, we understand the data requirements of the system. Actually, in this stage we do many things, but here, as we are discussing the database management system, so I will say that we understand the data requirement of the system. We specify these requirements in a detailed form, and after getting these requirements we design a conceptual schema, and the result is conceptual design. So whenever we are going to develop a software, we gather some data and analyze the gathered data. Actually, that is about the requirements for the application development, and after that we move towards the design stage and we develop a conceptual schema which becomes the conceptual design for the software which has to be developed. Once the conceptual schema is designed, after that we move towards the logical design and then physical design. In conceptual design, we make a fundamental sketch, or say basic sketch, of the system, in which we don't specify the detailed information about the attributes or the features of different values in a system. In simple words, we don't specify the data types of attributes or columns in tables. In logical design, we specify the attributes of the design system, and in physical design, we specify the implementation details. The conceptual design and logical design, these are independent of a system, while the physical design also focuses on the DBMS as well as the system on which the database has to be implemented. Okay, now let's start the ERD, Entity Relationship Diagram, which is about the conceptual database design. The entity relationship diagram is a semantic data model used for the graphical representation of the conceptual database design. By semantic data model, we mean that it has some sort of meaning, or we can say it is a meaningful model, and it is actually a graphical model which gives some representations about the conceptual database design. With a semantic data model, it becomes easier to design the database at the first place, and secondly, it is easier to understand later. In the beginning, we can easily define a database by using the ERD, and once this ERD is developed, after some time, if somebody wants to know about the database, then he or she can easily understand the database by looking into the developed ERD. It is independent of any particular implementation of the database. That is the conceptual database design expressed in ER data model can be implemented by using any DBMS. Since this is conceptual design, this is not physical design. So in physical design, we talk about the implementation and selection of DBMS. but in logical and conceptual design, we don't discuss the implementation details. So this model is independent of any system. We can say that it is independent of any DBMS. Suppose we have an ERD uh, drawn on a paper or developed, designed in a tool. So that ERD can be implemented in a DBMS. For example, it can be implemented in MySQL, it can be implemented in Oracle or in SQL Server. Developing it in a semantic data model makes it much more expressive and easier to understand. That's why we first develop our conceptual database design in ER data model and then later transform it into the database model of our DBMS. This thing is very common. Whenever we develop a software, we first design the software. So if we have an application that has database, so for the database we must have an ERD in the design phase. So once the ERD is developed, then the implementation of this ERD or the development of the software becomes easier. These are the main components of ER model. We have entity type, then entity set, attributes, and relationships. The entity set comes under the entity type, so we can also consider it as a set of three major constructs which are used in the ERD. So we have entity type, entity sets, attributes, and relationships. So whenever we are going to develop an ERD, actually it is designed, so I can say that whenever we are going to draw an ERD, then in that ERD we will have entity types, entity sets, attributes, and relationships. Now here we have entity type. What is entity type? Entity is a thing in real world. It can be anything, like we have student, we have location, vehicle, we have class, classroom, course, subject, anything that exists in the real world and that can be recorded, that is entity type. And that thing must have independent existence. It can be object with a physical existence like student, chair, car, house, employee, etc. Or it can be an object with a conceptual existence like company, job, university, course. In ER diagram, it is represented with this shape, a rectangular shape having single line for regular entity type. Then we have entity set. Here in one entity we may have different instances, like if you look into this student, then under this students we may have different students. We may have 50 students, 100 students. Consider your class, so I can refer all these students in your class as students. So there are many students under entity type student. So we may have many students under the student entity type. So the set of these students is called entity set, while the students individually or each student is an instance of entity type. So we can say that for each entity there are multiple instances. We have student entity type, so there are multiple instances of student entity type. The Group of instances form entity set. For example, student is an entity type. So here we have two instances, and these two instances can be said as an entity set. The entity type describes the schema or intention of the database. The entity set describes the extension of the database. Next thing is weak versus strong entity types. For this, we have an example. Here, we have two entities, imply and dependents. Now, suppose we have two tables, the imply table and dependent table. These are actually the two entity types. So in imply entity type, we have three entries, and dependents, we have also three entries. Now, if we look into dependents, it has an attribute, imply ID, which is used to connect this table with the implied table. We can say that there is relationship between these two entity types or relations or tables. Now, suppose I delete this entry E001 Ali from imply table. We can say that this imply left the organization. So in the dependents table, we have an entry for this E001 here, which is D001 Arshan. Now I'm going to delete this one. So this one got deleted. Here, this entry in dependence table is now in dingling position. It has no relationship with imply, though it is giving an imply ID which is not present in the imply table. Means that this dependence is not independent entity type. It has relationship with imply, and if the entry in imply is deleted, then the entry in dependents would be deleted automatically. So we call this implied table as an independent table because it is not affected with any deletion or insertion in the dependents table. However, this dependents table is dependent on imply. If we delete a record in imply, then the dependents table is also affected. So this imply is known as strong entity, while the dependents is known as weak entity. The strong entity can be represented with a rectangular shape with single line, and the weak entity can be represented with a rectangular shape with double line. Weak entity, an entity type whose instances cannot exist without being linked with instances of some other entity type. They cannot exist independently. We have example that there is an organization, and in organizational data we are maintaining the implies data and their vehicles. So if an employee quits, then there is no need to keep record of vehicle associated with that employee. So in this case, the vehicle table or the vehicle entity type is dependent on the implies entity type. Vehicles table is now to be considered as a weak entity type because it is not independent, it depends on the imply entity type. Next is strong entity type. A strong entity type is the one whose instances can exist independently without being linked to other instances. So in the example, imply table, is a strong entity type because it is not dependent on vehicle's entity type. If we delete an entry in the vehicle's entity type, there would be no effect on the implies table. The next component in ERD is attributes. Each entity has a list of attributes. So what are attributes? Attributes are the properties that describes an entity type. For example, the imply entity may be described by attributes name, age, address, salary, and department. Here, if we look into these two tables, the imply and children, these two are entity types. Imply ID, name, address, these are the attributes of imply, while dependent ID, name, and imply ID, these are the attributes of children table. Each attribute has a value. The value becomes the major part of the data stored in the database. So we store our data in the tables under these attributes. These attributes can also be referred to as columns in tables. Attributes can be simple or composite. These can be single valued or multi-valued, and stored or derived. So these are the three categories of attributes. Here we have an entity type imply. This one is entity type, and these all are attributes. For drawing an attribute, we use oval shape. However, the lines may be different due to their types. Now, if we look into experience, it has a dotted line. If we look into imply qualification, it has double line, and this address is also further divided into two sub attributes. So there are different types of attributes, and all these attributes are represented by oval shapes. All these attributes are associated with an entity type, or we can say that all these are connected with. The next thing is domain of attributes. Each attribute must have a particular set of values known as domain. We can say that each attribute is associated with a value set, and that value set is known as domain of values or domain of an attribute. What we do with this domain of values? Actually, we specify the set of acceptable values for an attribute. Now, we have record of students in a university. So what would be the possible values for age attribute? The first thing is the age should be a numeric value. I cannot type high, low, average, very high values under age. There must be numbers 5 or 10, 20, 50, something like this. And there might be range for age, like here we have 17 to 60. So for age attribute, the values must be numeric, and the values must be from 17 to 60. So this restriction or this set of values is known as domain of an attribute. Now we are coming back to the categories of attributes. So the first one is single versus composite. What is composite? Composite attributes can be divided into smaller subparts. These subparts represent more basic attributes and independent meaning. We have an attribute, and this attribute is further divided into subparts. These are three subparts of this attribute. Here you can look into this address. This address can be further divided into street address, city, state, and this street address can also be further divided. So this is the form of composite attribute. We can say that name, and under name we have first name, last name, and so on. Address attribute of imply entity may be subdivided into these all. The subpart may itself be a composite attribute. Here this one is composite attribute 2. If there is only single attribute and it is not further divided, then this attribute is known as simple or atomic attribute. Now if we look into this figure, this address is a composite attribute while these all are simple or atomic attributes. Next is single valued versus multi-valued attributes. A simple attribute may store a single value or multiple values. So in most of the cases, single value attributes are used in a particular entity type, and these attributes are known as single valued. For example, under age, we give a single value for age. An attribute can have more than one values, and that attribute is known as multivalued. For example, subject. Under subject, we may have more than one subjects. A multi-value attribute may have lower and upper bounds. This is used to put a restriction on the number of values allowed for each entity. For example, the subject attribute may be restricted to have between 3 to 6. The multi-value attributes can be represented with this shape, oval with double line. Now if we look into this imply qualification attribute, this one is multi-valued attribute. This symbol has double line, and if we talk about imply qualification, then one imply may have multiple qualifications. Rest of the attributes are single valued attributes. Next is stored versus derived attributes. Some attributes may be related. For example, age is related to date of birth. We can say that age is actually calculated while considering the date of birth. The value of age can be derived from the current date and the date of birth of a person. So age can be said as a derived attribute. Date of birth attribute is now stored attribute because it is not calculated, it is actually inserted in the system. Another example is number of employees of a department. It can be derived by counting the number of employees in the department. Suppose we have a table having employee names and their departments. So we can select and count the values under department attribute to know the number of employees in a particular department, and the number of employees in a particular department would be derived attribute. The symbol used for derived attribute is an oval shape with dotted line. In this figure, experience is a derived attribute. This experience is calculated by summing up the experiences of an employee. One employee may have worked at different organizations for different time intervals. So all those time intervals at different organizations are summed and the experience is obtained. So this experience is derived attribute. Today, let's say today I have 5 years of experience. Tomorrow it would be 5 years and 1 day if I am still working. So this experience changes with the passage of time or day by day, and it must be derived. It must be always calculated whenever required. This is another example for student. Here the age is derived attribute, skills, this attribute is multivalued. One student may have multiple skills. Session is composite attribute. Name, fname, these are simple attributes, single value attributes, stored attributes. Next thing is relationships. Relationship between entity types exists when attribute of one entity type refers to another entity type. Employee ID is present here and also here in this table. So this employee ID is referring to the employee ID in employee table. So there is relationship between these two tables. We have example here. When department attribute in student entity type refers to department entity type. We have a student entity type and department entity type. These are two tables. So there would be some common attributes in these two tables or entity types, so that these two may be connected just like these two tables. The diamond shape is used to express the relationship. Now, if we look into these two tables, here we have department ID inside the student table, and the values under this attribute are referring to the values in another table known as department. Now if I want to know the department of Ali, I can get the name of department for Ali in this table, which is IOC. For Salman, the department is physics. Physics is obtained by following this department ID. These are the symbols for ERD diagram. These all are used. We have an example here. We have department entity type, name, number, manager, manager start date and location, these are the attributes, and name and number, these are underlined, means that these are the primary keys. Actually we have the composite key, we will study about these in the coming lectures. So this department has some simple attributes and a multi-value attribute. Next is project, it has some attributes here. Then employee, it has simple attributes, multi-value and composite attribute. This one is composite attribute, this one is simple or stored attributes. Dependent with 5 attributes, all are regular attributes or simple attributes. Now this is a complete ERD. Here in this ERD we have employee entity type, department, project, and dependent entity types. Now if we look into employee and dependents, both have relationship, it is connected with dependents, and here this symbol is used for relationships. And if we look into the lines for this dependent, we can say that this is a weak entity, it has some attributes here. Next is employee. Employee has a relationship with itself. One employee can supervise another employee, so we can say that there is a relationship known as supervision. Employee works for a department, so there is relationship between the employee and department labeled as works for. Department controls projects, the relationship here is controlled. Employee also works on project. So this is a complete ERD diagram for describing the entity types, their attributes. This is entity type, these are the attributes and relationships. The diamond shapes are used for relationships. Thank you.